In this example, we again want to find p hat to start out with. Once we find p hat, then let's also find p, q, and then plug everything into our test statistic formula. So in this case, we say well-known brokerage firm executive claimed that at least 37% of investors are currently confident of meeting their investment goals. An XYZ investor optimism survey conducted over a 2-week period found that 119 randomly selected people, only 49 of them said they were confident in meeting their goals. So there's where we get our p hat, our test statistic, 49 out of 119. So we'd say p hat equals 49 out of 119. This is a 1. And that's going to be, again, we'll use about 5 decimal places just to minimize any rounding errors. So that would be 49 divided by 119. So we'll say 0.41176. So that's 0.41176. And double check I got that right, 0.41176. Now our p, of course, is given to us in our null hypothesis, but if it wasn't, then we'd have to go back to the original problem and we'd find either what we're calling the population proportion or the proportion that we're assuming to be true. So in this case, we're assuming 0.37 is the proportion that is true. So now we'll just plug everything into our test statistic formula, and since this is for a z-score, or for a proportion rather, we would have p hat minus p all over under a square root p times q all divided by our sample size n. So p hat, of course, was 0.41176. P, we're saying, is 0.37. This should all be over square root of course, we're going to use 0.37 for our p. Q is always 1 minus p, so this will be 0.63. And n in this case is 119, the size of our sample. So plugging this into our test statistic formula and using parentheses appropriately, we have 0.41176 minus 0.37 divided by square root parentheses 0.37 times 0.63 divided by 119, and we'll close the parentheses. So notice everything in the parentheses is considered to be under the square root. So I get a test statistic of 0.9435. So we'll say z equals 0.9435. So 0.9435 is my answer that I would plug in here, 0.9435.